So this question is really easy. You just need to split the integral and then take the constants outside to make things easier. So 36 over pi cubed times the integral of x squared dx minus 15 integral of sine 3x dx. So 36 over pi cubed, the integral of x squared is x cubed over 3. This and this cancels, you get 12 minus 15 integral of sine 3x. You can use this if you keep forgetting, let's say, the integral of sine, cosine. Through practice you will be able to remember, or if you can try memorizing them. But then again, if you feel like this will assist you, then sure. The easy way to remember this itself is sine, cosine, minus cosine, you go back to sine. So, and you can, if you want, you can shape it yourself, as in, what's the derivative of sine? You should know it's cosine. What's the integral of cosine? You should know it's sine. So derivative of cosine minus sine, and so on. It will be a cycle. You'll just know what to fill. So, of course, this doesn't account for the fact that when you do integration, you have 1 over k if you have kx over here, for example. So in this case, it will be minus 15 into sine, integral of that will have minus cosine. So minus, and here 1 over k, so 3 cosine 3x. And in this case, you have plus c because both of them are indefinite, indefinite integrals. So we said here 12, and then 3 with this 5, minus with minus cancels. Well, technically, you get a plus. So 12 x cubed over pi cubed plus 5 cosine 3x plus c. And they just want the I of pi, where they say this is I, so this is our I function. This is I of x. So what's I of pi? I of pi is, here pi, the pi cubed cancels with the pi cubed. You have 12 plus 5 cosine 3 pi. One easy way to do this is just immediately, well, actually, if you want to do it with a calculator, you can, but you can just go with cosine of 3 pi can be written as pi plus 2 pi. Cosine's period is 2 pi, so this will make no effect. Basically, what will happen as a graphical intuition is that whatever angle you had, which actually is pi, so let's say like this angle will be going like that and back here. So you did nothing, basically. You did nothing at all when you add 2 pi. So because we're back to the same place, you can just cancel. So cosine of pi, it's 180, and we want the x. This is cosine, this is minus 1. Why am I telling you this rather than calculator? This will actually honestly help you sometimes, especially with intuition and all that. So yeah, so 12 plus 5 into minus 1. So you basically get minus 5. 12 minus 5, you get 7. And that's pretty much it. For number 35, again, you split the integrals, so you get integral of 109 to x squared dx plus the integral of 8 dx plus the integral of 3 pi secant squared pi x dx. So now you just integrate normally. So 192 x squared, integral of that is x cubic. 192 over 3, that you get 64 plus 8x plus, this is 8x by the way, so plus this one, because if you do, let's say, the integral of a derivative of a function dy, then you get the function itself, because this is an antiderivative and this is a derivative, so they cancel each other and they give you the function. So basically, if you derive this and then if you integrate it, you get y, because you're deriving, then you're not deriving anymore, you're removing it, integrating it, so you get the function itself. So with that, is secant squared pi x a derivative, or even the entire expression, doesn't have to be this only, is this a derivative of a function that we already know? Yes, it's tan. So in this case, you'll get tan of, don't put this, because If you put this, then you're saying integral of tan. You cannot simplify this and then somehow have the tan on its own. Of course, you have stuff here, stuff there. So if you write tan, don't write the integral, because tan is gotten from the integration of the derivative of tan, which is secant squared. So tan pi x, but we're not done. We have pi x. So if you integrate a derivative, you're gonna divide by the derivative of what's inside. So 1 over pi times 3 pi. Pi and pi cancel, and you're left with 64x squared, no, a cubed, plus 8x plus 3 tan 3 pi x. And then just substitute 1 over 4, so you get for this one 1 over 4 cubic, you get 4 4, so 16, I think. So 64 over 4 cubic. You get 1 actually, yeah, 1. Plus 1 over 4, you get here 2, plus 3 tan of pi over 4. Pi over 4 is 45. Sine of 45 over cosine of 45 gives you 1, because they're the same, radical 2 over 2. So here you have 1 plus 2, you get 3. Plus 3 into, here you get 1, so 3 plus, so you get 6. Final answer. So for this one, again, you need to break the integral. So 12 integral of cosine x dx plus minus actually minus 6 into the integral of sine x dx, and then this is equal to integral of cosine. You get sine, so into sine, actually no need for parentheses, sine x minus 6 into the integral of sine x is minus cosine, so here like that. So 12 sine x plus, because minus minus, 6 cosine x, and you have plus c because it's an indefinite integral. This part is ix, as they said over here, ix plus c, and we just want to substitute theta. If you substitute theta, they told you if you do the theta, you get cosine theta being this, sine theta being that. So it's 12 into sine is, we have 3 over 5, plus 6 into the cosine, which is 4 over 5. This is fairly easy. If you do the addition, I believe you get 12. 12 times 3 over 5, 36 over 5, plus 6 times 4 over 3. I mean over 5. Whoops, my bad. Let me just fix this. Minus 6 times 4 over 3. Okay, so you do get, yeah, okay, you get 12. That's pretty much. I just had to double check. So just split the integral for this. You get integral of 2x over x to the power 4 dx, plus the integral of 7, I mean not plus, this is minus, integral of 7x squared over x to the power 4 dx, equals, this cancels with this, so you have 3, this cancels with this, you have 2, and if you want, I'll write it like this, minus 7 into the integral of, this is minus 3, x minus 2, equals 2 into the integral of this, you divide by minus 2 into 1 over x squared, minus 7 into, you know, add 1, you get minus 1, divide by that, you get over minus 1, so actually the minus and minus cancels, you get 7 here, and plus 1, you get minus 1, so 1 over x. Let's continue here. This and this cancels, so you get minus 1 over x squared plus 7 over x. And of course, this is an indefinite integral, so you add plus c and dx here. Don't forget, if this is written, well, it is written, but yeah. So I of 1 over 3, this is I, this is taken to be I. So I of 1 over 3 So I of 1 over 3 is 1 over 3 squared 1 over 9, and then there's 1, so it becomes 9, so minus 9, plus 7 over 1 over 3, so 7 times 3. Here you get minus 9 plus 21, you get 12. 12, yeah. pretty much. So distribute the secant x and split the integral. You get integral of 8 square root of 2 secant squared x, secant x tan x dx, don't forget the dx, minus the integral of 7 secant squared x dx. And this is an actual derivative of a function which is secant of x. So the integral of a derivative gives you the function. So this is the derivative of that. The integral of this gives you this. So 8 square root of 2 times secant of x minus this is the derivative of tan of x. So the integral of a derivative gives you the function, so minus 7 tan of x. And this is nothing special, plus c, indefinite, so plus c. This itself is I of x. So this is equal to or I of pi over 4 is equal to, replace pi over 4, so 8 square root of 2. Secant is nothing but 1 over cosine, so of cosine pi over 4 minus 7 of or times tan of pi over 4. And with this you get so first of all 8 square root of 2 cosine of pi over 4 gives you 1 over radical 2, or radical 2 over 2, same thing. If you rationalize, you get radical 2 over 2. So 1 over radical 2. So 1 over radical 2 gives you radical 2. So times radical 2 minus, you can do this with the calculator, but I prefer doing it mentally. 2 radical 2 gives you 2. So 8 times 2 you get 16. 16 minus 7 you get 9. So your answer is 9. So for this one, you need to go back to using u equals. We pick the one that is useful. So if we pick x squared, it gives us a derivative of 2x. 2x does not help us with this, useless. So we're gonna try picking this instead. So if we do the derivative of this, you get 3x squared, and it is helpful because these two cancel, because you divide by the derivative. So this is a much more useful choice rather than that, very useless over here. So you pick x cubic plus 9. So du over dx, you get 3x squared. Rearrange dx, and here du, so du over 3x squared. And let's go back to the equation itself. So this becomes the integral of x squared over 3x squared times radical of u, because we said this is u, times du, because this is put instead of this. All I did is take the denominator and put it there just to cancel those two immediately. You're left with the du. So this is what you get now. So let's keep on going. And these cancel, so you get 1 over 3 integral of u to the half du. So 1 over 3 integral of this, add 1, you get 3 over 2. Divide by that, so you get 2 over 3 times 2 over 3 u square root of u, because u to the power of 3 over 2 is nothing but u and u half, and this is u half is nothing but square root, so pretty much those two multiply, so you get 2 over 9 u square root of u, and let's replace back u by its original value, which is 2 over 9 into x, this is u, x to the power of 3 plus 9 into square root of x to the power of 3 plus 9. Now this is nothing, you can do it in the calculator. Actually let's do it, it's faster. So it's 2 over 9, but this is plus c, this is plus c, yeah, plus c and this itself is I of x, and I of 3 is so let's put that in the calculator. You get 2 over 9 times 3 to the power 3 minus, or plus, actually plus 9 times square root of 3 to the power 3 minus 9, no, plus 9, yeah, you get 48, which is the correct answer. So pretty much. So for this one, it's like the previous question in that you need to pick your u. Your u is the most useful function. If you pick secant, you are not gonna find anything useful. Secant squared, again, you're not gonna find anything useful. Tan squared, there's an easier way, and that's tan. So you end up picking tan. So your function would be tan of x. Now du over dx gives you secant squared of x, which is why it's useful, because those two divide when you do this, of course. Dx is du over secant squared x, and this is where they divide. 21 integral of tan, we said tan is tan x is u, so u squared, times secant squared x over secant squared x, I got from here, times dx, no, times du. These cancel, so we're back to square one. 21 u squared du. Now the integral of this, you get u cubed over 3. This cancels, gives you 7 plus c. 7 into, let's replace u by tan, so tan cubic of x, and we're done. Part c, plus c, I mean. And this is pretty much I of x. So I of, they're asking pi over 4, so pi over 4 equals, put pi over 4, you get 7. Tan of pi over 4 is 1, 1 cubic is 1, so you get 7 here, and you're done. So for this one, there's nothing special, but if you want, you can use the u again. Of course, you will not be picking a function here other than this, because there isn't a function. This can be considered a function, but its derivative is 0, and it's nothing you really want to work with, so just pick the obvious one. So x plus 25, du gives you 1, d over dx, and dx gives you, of course, du, because 1, so no need to even work with it. So you get this function becomes the integral of 2 over, this is u, so cubic root of u du. So basically you can integrate immediately. If you want, I'll take the 2 outside. So 2 into integral of this. This is the same as u to the power of minus, because it's down, and 1 over 3, because it's cubic root. So if you add 1, you get 2 over 3, and that's your new u. I mean, after integrating, of course. So divide by 2 over 3, so you get times 3 over 2, and here you get u 2 over 3. So this cancels, you get 3 into u is originally what? X plus 25. 2 over 3 is nothing but squaring and then cubic root of. Square can be outside or inside, doesn't matter. So yeah, so the 2 up is for squaring, cubic root. If you have to power 3, it's to the power 3, to power 4, to, and then over is the square root or the cubic root or the so on and so forth, basically. So yeah, and they just want to substitute the value. So 3 times, let's put this in the calculator. So 100 plus 25 is 125. Square of this, you get a huge number. Cubic root of this, you get 25. So 3 times this, you get 75. And by the way, this is plus c, and we want, again, this is plus c, and when we substitute, we actually substituted this as I of x, and this is nothing but I of 100, just to be formal. And yeah, pretty much. For this, pick the best choice of u again. Cosine x gives you sine x, but sine x does not cancel with sine cubic, or like as in cubic of sine, so sine to the power 3 of x, it doesn't cancel. You're left with sine squared x if you cancel, or try to cancel. So picking the higher power is better here, because sine other way, because sine and cosine are like, they're not inverses, but yani their derivatives will give you the other, yani. So pretty much, so u equals sine of x, and du over dx gives you derivative of sine of x is cosine of x, and dx equals du over cosine of x. And if you go back to the equation, you have integral of 32 cosine x over cosine x times sine. We said sine of x is u, so u cubic times du. This and this cancels, so you are left with 3 on 20. Integral of u cubic is u to the power 4 over 4 plus c. 4 and 3 to 0 cancel. You get 60, no, 24, no, 80. Yeah, 80. 80 into u, use what? U cosine, right? So cosine, no, sorry, sine. So sine squared to power 4. So sine 4x, yeah. Plus c. This is I of x. So I of pi over 6 gives you 80 into sine of pi over 6. Let me just fix this. So sine of pi over 6, all of this to the power 4. I wrote it differently just to make things clearer, just to know that what is sine 4 over this. So it's this, sine of this to the power 4. And yeah, pretty much. So sine of pi over 6, if you know it mentally, it's half. So it's the 2 to the power 4, it's 2 times 2, 4, 4 times 16, so 16 over, but we can double check. So sine of pi over 2, pi over 6, you get half. This to the power of 4, you get again 1 over 16, just like how I said it. Times 80, you get 5, and that's your final answer.